So, shall we start? Okay. Now, this is again just a quick review of the path that we have gone so far. So, I will often refer to that. This week there are 3 classes. We are talk about this technology readiness level where I left off. In probably it will take me 2 classes for that. And in the next one is that I am going to tell you about a project work that you have to do. This is very important for the grading purposes, because like we said, the grading is based on the assignments, some of them will come plus class interactions, and this is actually making you apply your mind to a given situation. So, it is a fairly important thing. I will describe what is a project thing and things like that, how to do. It will be a group project, because there are 31 students registered and at least 24-25 come regularly. So, 24 projects if I have to give you and then review, I am dead. So, what I would do in that class, we will talk about how you can make into smaller groups and combined project for the entire group is acceptable. That is what is the plan for that. Okay. So, for this class and next class is we are on to this so called technology readiness level. Okay. Where we pick up from is going back on the previous classes after the shift from cost, finance and all that. We talked about research, technology development, the progression, applied research, basic research and so on like that, and where it was felt that a research idea finally if it has to become technology, technology itself being a complete set of a new way of doing things to achieve some end result either of a product or a service, and a new technology must be always seen with what we already have, because it is almost always the case there is a technology exists for something. So, therefore, if anything new that has to come and you are engaged in technology development of that kind, you are creating something new, you have to compare that with what is already available and then be clear as to what are the advantages over the existing one and why somebody will find it much more interesting to pay money and buy it from you. So, that is the funda. This will pick up from there as what is technology readiness level. This is again a very useful concept, more from understanding, and also it is very often you go to any large meeting, policy makers, seminars, this TRL will get bandied about. It is like nationhood. Nationhood you do not discuss, right, nationhood. Like this TRL is often used with completely different probably understanding on the part of everybody. So, if there are 20 people inside the auditorium and talking about TRL, there 20 different thoughts are going on most of the times. So, this is my experience. So, I thought we will get a hold on this concept of TRL, what it is, how is it used in this lecture. Now, TRL is, as you can understand, is related to the progression of an innovative or interesting idea into implementable technology. This is what we saw in the classes between a research idea and actually finally something getting implemented, there is a lot of sequence of activities. So, in this context, technology readiness level means that someone talks about a particular development, then in your mental frame you have to be clear, is it at starting point or is it very close to the end point. Now, starting point and end point are very easy to define. Starting point is you get a very interesting idea of something very different which can be much better than the existing way of doing things, some idea. So, ideation is the starting point. The end point is actually a plant being built on that idea which is ready for operation. So, that is, so these two end points are very clear. In between, where is this person talking about, where is he with respect to that is a mix, which is why there is lot of difference of opinion comes. Somebody believes he is very close to the end point, nobody is interested. The opponent party says he is right at the beginning and therefore, lot of work has to be done like that. So, in this progress of innovative ideas to implementable technology, TRL figures. It is just an index which is qualitative it is not very scientific, some guidelines are available, but you will get a plus or minus idea of are we here or are we here. So, that is the purpose of the steer. Now, I have also shown in smaller print this progression of innovative ideas to implementation technology. The context is there can be two contexts, one is an academic research context, the other is inside a company. Depending on this slightly it changes. So, first is the ideation of something better than what we already have can happen to any person, and that person can be engaged in academic pursuit, he can also be in companies working for the companies, manufacturing company, EPCM company, technology development, anybody can get a better idea. If you are suddenly you think you get an inspiration, why not? These days TV ads are also coming, why not? So, that is it. Then what happens is the immediate step is after you get an idea you just want to test it out in some form or other, whether that idea is what is it, just give some shape. So, we normally do a little bit of a testing of that idea in the lab, see what the results are, and then think maybe this has got a benefit for an end use. So, that initial ideation part is what is done. This part is common whether you are in academia or whether you are in industry companies, unless you are one of those rare guys like me. When I said I have got a great idea to produce sulfur, go to Mars, collect the H2S and come back here. Excepting for that kind of a guys, most of the guys do this ideation, little bit of work here and there, and then figure out if this happens maybe there is a benefit here, okay, they get it. At this point, if you have really come out with a much cleverer idea as supported by a small experiment, you have two choices, and this choice depends on whether you are inside the company or you are inside an academic institution. The first thing is everybody says for protecting my interest, because tomorrow I may want to make money out of this idea, I will go and see whether it is possible to patent it, whether it is possible to patent it. Everybody wants to patent an idea, but we just saw in one of the classes what is possible to patent, what are the laws, etc. So, but the urge will be at least let me try and make the initial step of getting it. This is common for everybody there. After that there is a small fork. If you are in academia, mostly your interest will be to let the world know that you have got a great idea like this, which is in terms of publishing papers in some nice journals. So, if you publish, everybody cites that publication and then your citation index goes up and all. So, that is the fork that people in academia take. After you take care sufficiently to make sure that you are the author in terms of patenting, publish it. And we said that in terms of companies, this is not the preferred path. I mean, why would they want anybody to know what are they got? Of course, they are supposed to have ideas. So, publishing is not very common in companies there. Then is the next step is up to this good idea, small experiment, test it out, seems to be potential, take care of your interest, what next? Again there are two roads split into two paths. Almost invariably, not always, almost invariably in academia the road is go on to the next idea. Okay, I have got it, I have got an idea, I have probably got even patent application filed, I have published it so that everybody knows I am the creator of this idea. Now, look for the next great idea and continue work. This is the typical of an academic institution, unless you are Donald, this guy Sadoway, working for 20 years. In companies, this is very different. First of all, there is no publication in a peer reviewed journal and all that. They think, okay, we have come up to this part of this idea, what is the next with the same idea? You are not jumping to another idea, maybe another, you may get a different idea, but you are not let go, you have come here, what are you going to do next? Because the pressure there is pick up the idea and finally take it towards some product or a technology or something which starts making money for that. So, the pressure for commercialization is very high in companies because they benefit a lot. Now, from this at this stage, if you choose that I have to take the next step, whatever the next step is of the same idea, you will require money, at least apart from other things you will require definitely money. Where to get the money? In academia, the thing is the funds are usually in that order. You get some government grants, because every government, every national government is giving out some money to get creative new ideas like that. So, you get that grant, that is possible, but the flip side is there are too many people chasing government grants. If you take India, I think in one of the context to Mr. Stalin, people asked, why do you have so many chemical engineering colleges, so on like that, right. So, he also answered. Similarly, if you take India, I think has close to probably 20,000 colleges at a minimum. You can read, there is a report Ministry of Human Resources publishes, very large number of colleges, and in every colleges there are researchers and students finding they want support for doing ideas, and all of them run to the same government agency and ask, and the government agencies are also pretty democratic. They do not want to be taking sides of only a few colleges. So, even if they find there are small differences here and there, they would sort of spread it out. So, it is again that is one way. Sometimes trusts and philanthropies set up some money to encourage research. So, that is you can go through Bill Gates Foundation in US, here Narayana Murthy has got one, I think Wipro's chief, past chief at least, he had some foundation like that. There are some foundations available, and against running companies, government recently, I think about 10 years back, they came out and said certain percentage of their profits must be set aside for something called corporate social responsibility. This is a law that was passed in India. Every Indian registered company making registered in India, some percentage of their profits they have to set aside for spending on items called corporate social responsibility, CSR it is called. That is one source, and spending money on academic institution is encouraged. I thought so that is one way of up to CSR, but the second part of that companies is obviously the companies are all the time interested to do better for the future. So, they are also looking for innovative ideas to support the innovative ideas, like in one of the earliest slide I have said is that this happens particularly technology development companies more than the manufacturing companies, more than the EPCM companies. The technology development companies all the time are looking for scanning the world including academia, where are the bright ideas, so that they can pick on the bright idea and then take it up further and develop it into a formal technology. So, technology development companies are all the time looking for funding. Like we said, those companies are not too many in terms of numbers, but they are available. So, in summary, if you are a researcher, these are all the fundings available. You can by now you would have made out that the most common source of funding is probably 1, 2, 3A. 3B is very hard, though 3B is jackpot. 1, 2 and 3, like I said, government gives, but because they have to give large number of people, each amount of individual researcher will not get a great amount of money. So, it just works out like that. Similarly, trust and philanthropy is also as much as possible they want to help several people. So, they can't be zeroing in on only 1 or 2, so on. 3B is jackpot, because if those guys who are running their companies, they spot the opportunity in you, and normally they spot the opportunity much better than the researcher naturally, right. Because we said in terms of qualification experience also, if you have to be in technology development companies, the highest level of skill in terms of your basic sciences knowledge you must have, highest of the 3, and you must have an excellent idea about what is likely to happen in the future in terms of global scenario. So, it is a wonderful combination of high tech and high business. Those companies exist. Therefore, they are in a much better position to spot the potential of your idea, probably even better than what you yourself will know. So, they are all the time scanning. So, that is one source of funding for academic research. Of course, companies, some other companies themselves spend money on research within their own companies. Government encourages a lot of this expenditure by giving tax concessions and so on. Now, here inside the companies, the ROC we discussed in one of the class, right, return on capital employed, which means if I invest that money, how much return I will get it in some measure or other, that is all the time running at the back of the mind. But here I have to, we are talking about not a running operation, we are talking about an innovative idea that could result in a profitable operation. So, it is a bit of a speculation about the future. Nevertheless, companies do an estimate of what is likely to be the jackpot return of capital, that they just do not ignore that they bring it into sharp focus on deciding whether to promote that idea and spend money on that idea. Here the emphasis is on, this is a key word that you have to remember, emphasis on market, likely market, because nobody knows what is likely to be the market 5 years from now. With perfection you will not have some idea, but nobody could have predicted exactly what all has happened in various. So, there is a bit of a guessing game there, but market is the focus more than novelty and so called creation of knowledge, because one of the things that happens is, why are you doing this research? Because I want to contribute to the knowledge of the world. True, you can't deny, but that is probably not the most sought after goal reason in companies to spend money on. Similarly, it is a novel idea, like we remember in patenting it said it should be novel, useful, non-obvious. So, most other sometimes researchers are guided by the fact they want to do something new better than I am the first fellow to find out. This urge goes on, it is a human urge, I will be the first fellow. So, what is the company's view? You may have a novel idea, but whether the idea really is likely to result in something is their call on that. Now, technology also I said is new technology development is an existing comparison and delta over that. This is very key, this is something absolutely essential to that. So, while doing this there are some peculiar situations that arise. The originator of the idea always says his idea is the best idea mostly. So, what I have called it is this Pygmalion, read up about, some of you would have who are literary minded would have known what Pygmalion is. It is a nice book by Bernard Shaw. So, you read through that, it is come out as movies and all that. So, it is that you like something so much you completely are unaware of what is happening around that. So, this is usually the innovators, researchers have this, they are so much committed to that idea. On the other side, guys who are considering that to fund it, they have got experience of 200 times failures. So, like I said, there are millions of patents, but few of the products, because sometimes some in between something does not seem to be click. So, the funding agencies, particularly commercial company funding agencies, all the time take a view, so you have got a great idea, is it? Interesting, very good, I have heard this before. So, there is a bit of a tension between the originator of that idea who thinks is the greatest idea that is going to change the mankind, and the funding agency which says that So, there is some tension, but instead resting on that as a personality disorder between A versus B, he will not listen to me, he will not listen to me, an attempt if you are able to get, and this is where TRL comes, is a reasonably understood transparent way of judging, it would be helpful. So, purpose of TRL came from saying have a consensus which is more or less based on some commonly known frameworks. You can judge an idea and say this is here and here. Closer to higher level of technology development, obviously the funding agency will find it much more interesting to fund it, because then the gap towards completion is less. If you are in a very preliminary area, they might say okay, it is a good idea, but probably you should spend some more time on it before that sort of. So, TRL helps even a researcher to have a clarity, and definitely for companies which are willing to take it up and promote that area to have a framework. Now, this is an important slide, you have to read it and reproduce in your own way. This is an index or kind of a indicator, TRL, it is finally a number between 1 to 9. this number tells you a given idea somebody is expounding, this is that idea I have got like that, how well it has been tested, under what conditions it has been tested, so that you can make up your mind on logical analysis. Is it ready for adoption? If so, how? So, that is a rather, my English, pardon me, it is a bit of a long sentence, but you get the idea, right. So, you have to just use that. It should have two things, it should have an index, means it should have a number TRL 2, 3, 4 like that it will have, and also it must have a logic of what is behind, what is below that. So, you must have a path, it is not a snapshot of a single number, it is a kind of a pathway. The pathway may be slightly vague, you are at this point is very clear, but the path is not dark, at least it should have some pathway going forward, that sort of a thing. I have now listed some novel ideas, few minutes we will take it to put this whatever we talked about TRL into perspective. You have all heard about this word perovskites. It is a form of a structure ABO3, molecules arrange, atoms arrange in some fashion. They have some interesting properties. One of the properties is, if you shine electromagnetic radiation, let me take light instead of complicating, if you shine light, visible, ultraviolet, infrared, depending on the nature of the perovskite material, that is chemical composition and structure, it can absorb a part of that and create electron hole pairs. Now, compare it with silicon, doped silicon, silicon also does that, all our PV cells which is on our rooftop is silicon absorbs wavelength of a particular light, generates electron hole pair, therefore, accordingly you can make electricity out of it eventually. But silicon is just one class of material. There are other class of materials called perovskites which have been found to have this property. They are famed to get, now we have to say, so what? It is interesting observation. Oh, we have heard something called perovskite, it creates electron hole pairs under some radiation, so what? Now, if your idea now is use this property in order to develop a photovoltaic device, if it is not the only approach, you can tomorrow somebody may discover it has got other properties, but if you take this one property which you have found out in the lab and then say, I am therefore thinking maybe this is another way of meeting the electrical generation in a renewable manner. If you want to think like that, then we are talking. What have you done? What level is it? How is it go forward? Because here in the 9 is a solar system working on perovskite generating electricity. This side is oh, this molecule has this property, is it? Is probably TRL1. So, that is one thing that we have to. Second example is same on solar, there are certain dyes, actually dyes are colorful, right. We are dyed purple, green, yellow, it is because the chromophores in the dye molecule selectively absorb and selectively reflect, and that is why you get that color. So, the same thing is, if you synthesize a kind of a dye which will selectively absorb and create this electron hole pairs, that is another way of looking at electricity. So, there has been lot of research done on dye sensitized solar cells. You create a dye which is the energy harvester, and then you connect it to a redox shuttle which carries their electron hole pairs to the two terminals, and then you can connect it and hopefully get electricity out of that. So, that is here again the idea is what you are saying, one of the other way of making electricity from renewable sources. Another example could be, in your work and research you have suddenly found out a solvent, and the solvent has got a very interesting property of absorbing CO2 at a lower pressure even if at a higher temperature. That is a famed claim. What is this? Because all of us know that any gas absorption increases with pressure, decreases with temperature, but your solvent, nice solvent, it does not require too much of pressure, even at moderate pressure it absorbs a lot. Add to the beauty is that even if the temperature is higher than normal, it still continues to absorb. So, you think there is a good thing going in sense of, again practical engineer says, so what, here is something which at some conditions seems to be good, absorbing CO2, what would be the possible use of that idea? Wherever we think CO2 removal is required, currently it is being done. Most of you would have known what is the most common known method of CO2 removal from a gas stream. Absorption in something called ethanolamines. You would have hard potassium carbonate. In fact, the urea ammonia process rests on CO2 absorption and selectively stripping of that. So, now if you think they are using it, now if may solvent comes out, maybe there is a potential use there. It is going back to against something which is already existing. If you have got something better, you will collect data and so on like that. So, enough example. So, that is now in each of these ideas you are talking to somebody else, that fellow with lot of passion will describe about his work. You know what, I went to this AbO3, it is actually methyl atom coming here, and then this is iodine atom coming here, and this is ammonia coming here and all that, great thing. At the back of your mind, if you are commercially technology oriented, you will think, okay, therefore what have you done? For example, in the new solvent case, what is the data that you will be looking for as he is describing? What is that you will be looking for? Solubility of CO2, continue that. Everything is every solvent has solubility. If he gives a number, that number you will say under what pressure, temperature, very nice. So, you say you have got the solvent, it absorbs so many moles per liter of CO2 at X pressure and Y temperature, and then next step will be for you to look at what? Compare it with, all of us know ammonia plants are using CO2 recovery system based on methanolamine. Run up chemical engineers handbook Perry and say in methanolamine at what pressure and temperature how much of CO2 is absorbed, and try to verify. If it comes under comparable pressure and temperature conditions, your newly discovered solvent 15 times CO2 it holds, you are getting excited. If it is 6% more than the existing one, you will be excited, but not all that, right. So, intuitive. The second time what we will look for against comparison with the present one, okay, this got a good absorption. After you absorb, what should happen to that? Eventually you have to take it out also, no, otherwise what happens to the solvent CO2 mix? You are stuck with this solvent carrying a lot of CO2, okay. So, you will also ask a question, under what conditions can the CO2 be removed back, and if it turns out, oh, that is horrendous, you really have to take it to 10 power minus 4 pressure and heat it up to 500 degrees Celsius to get the CO2, because so nicely it sits inside the solvent, it does not come out, then your excitement of 20 times will probably drop down, because there is always you are comparing with that. The risk of this approach is you may be just missing the next biggest discovery in life, because you chose to compare it with monoethanolamine in some application, pressure, temperature, reverse energy required, all that you did, and for that application probably it was not exciting, possibly, but it may just be that an application which you do not know where this is a winner, possible, which is the reason companies which get into technology, they keep their antenna all the time. Something which is already they are making, they will know obviously, something which is likely they are heard here, there, they spend a lot of time in trying to not miss out on that. But the essential point of this discussion so far is, any new idea, when you talk to somebody else, you will have some discussion and come out at something called TRL, which tells you what work has been done and what more work is to be done for a given end use. If the given end use is completely different, you can be different. Okay. Quick background to TRL, how the whole TRL came into the picture is during the 70s. Remember, that was the time when there was a massive competition between United States and the then Soviet Russia of space research. People wanted to be the first and second and whatever. So, NASA was set up to give a push to space research on the part of the Americans. So, money was not a problem. Government decides United States shall be the forerunner in space research, then where is the question of money? So, and they felt that the Russians were slightly ahead of the time. Actually the first time when Russia set spacecraft into the space, it came as a shock to the United States, because they never thought that these guys would be capable of doing it. So, they were against a race of wanting to do better than somebody else. Money is not a problem, but they wanted to be, you do not want to put up something there, it goes boom, it goes. So, they were wanting in the developmental program of space research, lot of participants are participating. NASA is only a coordinating agency, right. So, they are working with large number of startups and companies and so on like that. Objective being something has to be pushed into space. Now, you are talking about insulation material, come and talk to me. You are talking about rocket engines, come and talk to me. You are talking about geostabilizing control system, come and talk to me. And they had to pick and choose and finally put it into the program, so that the final program of launching the spacecraft takes place. It was not a commercial criteria as it started, because nobody would say how much likely to be cost, is it much more efficient than that, and all that question was not asked. Is it proven reliable, is it likely to be done in the shortest possible time, because finally I want to put the spacecraft in the shortest possible time in the space. So, with that background this was developed. They came out with some indicators, if it is like this it is low TRL, if it is like this is middle TRL, if this is like this it is high TRL and so on. Now, we are now not talking about that kind of an environment, we are talking about a commercial environment where ROCE is all pervading, sitting and looking at us. So, with that in mind we can't just directly take whatever this is an important point, because people talk about TRL without knowing the background and the context in which TRL was developed. Then European Union, which is almost all minus United Kingdom, came out with some guidelines which is a little more practical, adapted to commercial use, because European Union is also now into a lot of advanced research. So, they came out with a guideline. This guideline is available, if you are interested you can Google it or I can share it with you. Let us not spend into, because it is a lot of English prose, this like that. Now, the last point which is relevant here is, as of India there is no unanimity of what is the framework. So, you can pretty much say whatever you want to say, and pretty much people say what they want to say. So, TRL discussions, keep that back of the mind. Key points are, it is 1 to 9 some number, 1 is in low end, 9 is near the commercial implementation. The discussion is there, I will post it so you can read through that. Let us say 9 at least, commercial version of the plant version 1, because there also after the first plant, second plant, third plant there is an improvement that takes place. At least the first commercially put up plant is called TRL 9. So, that is easier to remember. Now, two things which I will say, this websites please go through for yourselves, very interesting. Now, all this context is on technology development, ideas, where is it like that. So, some of the case histories of really what has been happening, the Chemical Engineering magazine, I think earlier one of the class I mentioned, Chemical Engineering magazine, once in 2 years they announce an award for companies which have come out with innovative technologies. Please go through that, it has been going on from 1940s, once in 2 years. It will be worthwhile going through their website and checking up 1 or 2 ideas. You will get a flavor of what kind of a thing that is happening. In fact, the recent one is taking CO2, converting it into chemicals. It is a fairly innovative idea, right. So, everybody is talking about global warming, of avoiding CO2 getting in, but now that there is a hell of a lot of CO2 already put into that, this one says how do you recover the CO2 and then convert it into useful chemicals. A workable technology is getting developed on some scale. So, the TRL work has been awarded. So, that is one of them. This is the site you can go through and see. One of you asked, I think question is, why Indian company, I have been repeatedly saying India there are not too many companies doing technology development. And just as a contrast, I belong to this Indian Chemical Council, which is the talk shop of all the Indian chemical manufacturers. All of us have got together and we talk. So, Indian Chemical Council also has a program to encourage what they call as this Acharya P.C. Ray is one of the chemical engineers of the 1960s, 50s. So, in his honor an award has been set up for development of indigenous technology. This is the name of that award in India. ICC is the person who is running it. There Chemical Engineering Magazine Kirkpatrick Award, India ICC Acharya Pisare Award. Here is the side, you go through that. They also say what as this is an annual award every year. I leave it to you, judge what is called as indigenous technology here, what is called technology there, just to give you an idea of perspective. Okay. Important point, if you finally accept some definition which is close to European Union in terms of what is TRL1 likely to be, what kind of a city is TRL2 and so on, if you accept it with some changes, what is of interest to us is ideas, originator etc. will happen in the TRL early stages. Now, you will be at a stage where some funding, effort, time has to be spent to further that idea to go to the next year, because finally when it comes to high TRLs only it is commercialized. So, in that path, if you are wanting to convince somebody to give you money and so on like that, what is likely to be the meeting point between the providers of funding and the idea creator? There has to be some where they tend to meet. It can be a slight overlap, but it can't be the so called gap which is remaining. So, one useful thing would be to take 1 to 9, midpoint is 5, 4 or 5. Actually that is the approach I have taken. You can argue with it. Somebody may say no, it should be at least 6, 7, then companies will get interested. Some forward looking companies may even be interested in 2, 3 or whatever, but take the midpoint for that. Now, at least at that point of time a minimum is this idea should have basic essential information to evaluate it. So, that is very relevant. You have to cull out from that idea, dig out, like this solvent example, lot of useful information you have to pull out, come, that is how we should decide on this. Point is, even if you have something called TRL4 midpoint between the researcher who is trying to develop the technology and commercial entities which are willing to fund that, they have come to some understanding, from that point onwards to go to 9 when the first commercial plant is set up, it is a long time. This is not anybody's fault. I would be very surprised if that time frame is coming down to much lower than this. Few examples I have given. Lithium ion battery, which is now practically taken for granted. If you look at the initial breakthrough idea, what is the, by the way, all of you know about lithium ion batteries, right? What is so great about that is that lithium atom, if it sits in one environment, there is a certain electrochemical voltage. Let us say as bare metal, lithium metal, electrons surrounding the atom has some potential, right, because of the. Now, if the same lithium goes into a metal oxide, some metal oxide and sits, it has got the electron has a different potential. So, the idea is some guy good enough, in fact this guy you must read up, called John Goodenough, he is 94, 95 years old, brilliant guy, still active in researcher, Google him, he is my favorite, John Goodenough. He discovered this property that lithium, if it is like this, electrons have one voltage, if it is in this environment it has got some voltage in the 80s. Then companies got interested. What are you saying is that they have two different potential, is that if there is a potential difference, then there is somebody is thinking if there is a potential difference, actually the batteries are all about that, there is a potential difference in electricity will flow, come on say it again, like that. Finally, Sony Corporation came out with the first laptops with the lithium ion batteries. The journey took that time. Second example is proton exchange membrane electrolysis. Between the fundamentals of what here the thing is, there is a membrane. The membranes can be of two kinds. Membrane after all is a porous structure, right. So, on one side of the membrane, other side of the membrane, anything can pass through or only a few things can pass through. So, in this case only protons can pass in one direction against potential difference, all other ions are stuck. This is a property of that membrane. From there to say that we can actually build an electrolyzer or a fuel cell, somebody jumped and said selectively if ions are going through then. Okay. Therefore, going back to this whole notion of technology development by now is it can be a big jump, completely unknown kind of a thing, like lithium sitting here, lithium sitting there is a breakthrough, who would have thought, or it can be a significant but incremental change. A particular catalyst is working, you study very deep about that and then try to say that is the reason the activation energy changes, is it? Now if I tweak it like this, maybe the activation energy will change slightly better, and actually you find it, you hit the jackpot. In ammonia technology, many catalysts that we use, that is how it started. The first catalyst is like trial and error. Subsequently, as knowledge improved, we knew about structures, electronic structures, your porosity, micropores, mesopores, what have you, pore size distribution. Then somebody can become better and better and say the same what we rejected, take it there, study it, do a small tweak, you get performance. So, technology development need not always be that biggest breakthrough that nobody else thought of. It can even be with sufficient knowledge gathered from all over the place. You can do slightly better than what you have, but it is a significant impact on that, both can be there. Key point is always keep it in mind, and this is going to be useful in your project work. That is the point I am trying to make, is check what is the existing situation and check your idea what you are proposing, how can it be delta. This is key to any technology development, and this is not obvious, you can get it, but most of the ideas when they are presented for whatever reasons we talk about, it is hyped up. So, if you take for example a research paper and read it, typically it is about 12 pages it runs and about 60-70 references are given. By the time you read it, it will take a lot of time. If you sit back and then say what is that has been done, it is very hard, because there will be so much written there. There is some X-ray diffraction data, and there is an EA spectroscopy data, there is this data, that data, 20 charts, and then cross references to every one of them. So, mind boggles, but the key to technology development is arising out of this mass, you have to pull out critical information. The guideline and the torch is something has already been there now, take that. Compared to this, okay, bright idea is coming from here, like to like, how does it compare? Then you are much better in assessing TRL going forward in technology development and so on. Now onwards, 2 more minutes I can take. What we are going to do is, your assignment is going to be like I will ask you, in the next slide I will show you some suggestions. You can come with your own idea. The project work is like this, you have to pick up some bright idea which has been published recently, 5 years. Think of that idea and try to see at what level of TRL it is, and if you want to take it to the next level, what additional work that you have to do. So, you are in the thick of technology development, something has come out, you have to, so that is to do that for you, your project, you need some practice, right. So, what I am going to do is that I will take some case histories of innovative technologies that has already happened. So, I will go through the history of this, how it evolved, this was like this and then this happened and this, like that, like a story I will come out with actuals, but this time it will be based on engineering analysis, calculations, heat transfer, mass transfer effects, the whole works I will take you through to show how somebody else has done it for those examples. Of course, it will be a 15-year story, I will compress it into short, I will give that. These are the 2 examples I am going to talk about. One is autothermal gasification of natural gas. This is a technology which development that took place. So, I will go through why, what was before, how it happened and all that. The other is caustic soda manufacture. I think briefly we talked in one of those classes in terms of new plant membrane process. So, there was caustic soda was, if you go through, originally was made something called a mercury process, then we switched to membrane process. So, same a different method, why, what, the story of the big disaster is there, but that will be in passing. We will come down to real hardcore engineering aspects of what was different, how it was done like that. So, this as a example I will go through with you, absorb it, then you will have to take up and do for this as a project work. Okay. Now, my favorite ideas are like this. Water electrolysis to produce hydrogen is big time, all of you will know. Right now it is the hottest topic. People are talking about green hydrogen, blue hydrogen, grey hydrogen, whatever hydrogen. So, hydrogen from water electrolysis is big time interest for everybody, and some of you also said that you wanted to be green economists, whatever. So, one of the key idea is that catalyst with this water splitting reaction is not taking place just like that, right. So, the activation energy is very high. So, you have to have a catalyst to bring down to a normal current, to a reasonable over voltage in current. So, there is a lot of work that is taking place. Actually water electrolyzers exist, by the way, it is not as if there is no technology. So, there is this meets the qualification of an existing technology, but on top of that if you want to come out from there, the catalyst that you use is likely to be very different. So, this is one area where you can take up, hundreds of papers are there, choose any one of your choice, come back and say where is this TRL, what it has to be done next. So, that is one choice. Lithium ion battery, big again electrification of vehicles and all that, lithium short supply, all that we are. So, there is a paper which is available, which is to say how can it be recovered from sea water. Normally lithium today existing is there is a lithium mines, nature has provided. If you are in the fortunate country which has got the lithium mine, extract it, sell it, but there are a few countries in the world, tomorrow if they put a choke on you, you are stuck. So, people are thinking what can I do for diversifying, and there is a report, there is a research professor who has said that if you are a coastal based country, at least India is, sea water say you can recover lithium. So, yes, come on. So, you can take that. Then another approach is lithium ion is the most commonly used, it is common, there are cars are running with lithium ion batteries. Okay. So, another research comes and says I have a metal air battery which is in some way it is better than, you can take that paper and do a TRL analysis. And at a smaller scale biomass gasification is well known, right. What is not known about it? There are 50,000 papers on biomass gasification, plants are running, you can gasify biomass, but it also lands up with a lot of CO2. So, one of the attempts is to have biomass for renewable part plus less CO2 is use solar energy coupled biomass is another idea. These are my 4 ideas. If you are okay with that, I will also share with you some other research papers, you can pick any one of them, or completely dropping all this, you can come out with your own idea on that. Okay. So, that is what is going to be happening. We will now take a break. In the next class I will elaborate this a little better and also help you to form these groups. My suggestion is there are about 20-25 people who are coming there, not more than 5, because then it becomes very difficult to even ask teams to work. So, would you guys among yourself form, or in the class will they mini like that, we will choose 5 whatever we decide, and then we will go forward. Okay. So, I will stop here and continue on Wednesday evening.